Hi, chemistry students. This is your Unit 2 lesson on converting Kelvin to Celsius, or an introduction to temperature scales. Now, you're going to need to take a very few notes, but you do need to have your notes ready to write down. You're also going to need a calculator. So if you don't have those things ready, pause the video, and when you are ready, we'll begin. Hi. So this is your introduction to temperature scales that we use in chemistry. Before we get started, and you don't need to write anything down at this point, I have a picture that I think is very fascinating. And take a look at this picture I've shown you, and I want you to think about what you think this is. Now, I'll give you a hint. In previous lessons, we've talked about the phases of matter, and we've talked about solid, liquid, gas, and plasma, and going in order of energy. This is actually something that has to do with phases of matter, a phase of matter that we have not talked about. This is actually something called a Bose-Einstein condensate. It's a colorized lattice of tornado-like vortices within a spinning Bose-Einstein condensate of rubidium atoms. This Bose-Einstein condensate is formed in an ultra-high vacuum at temperatures of only a few hundred billionth of a degree above what's called absolute zero. Such condensates are a new tool for studying quantum mechanics. And essentially, this new state of matter is what happens to matter when it is really, really, really cold, which means that the kinetic energy is almost non-existent. The atoms have almost stopped moving. And when they do that, they interact in a way that is just almost defies explaining. The best explanation is they act sort of as one, and they act as a super atom. So we need a temperature scale that goes down all the way to when the particles stop moving. Now, this is where you should write it down. The temperature scale we want is one that has an absolute zero. In other words, if temperature is kinetic energy, then we want a temperature that is zero, that is absolutely no movement. Now, 0 degrees Celsius is cold, but it's kind of arbitrary. It's based on the freezing point of water, and we know you can get colder than that. The Kelvin scale that we're going to talk about is one in which the zero really is zero. So you want to write down absolute zero. And again, remember, temperature is the measure of the average kinetic energy, the movement of the gas particles. And absolute zero on the Kelvin scale is when all kinetic energy stops. We've never really achieved that, but we've come really close. And so there is no negative, let me move myself here, there is no negative Kelvin. You can't have, and we know we deal with negative Fahrenheit, negative Celsius, but the Kelvin scale is based on the fact that zero means no movement. All right, so let me move myself again. And here are the temperature scales. And take a look at this right now, and then we're going to talk about a conversion. Now, we're all used to the good old Fahrenheit scale. And the Fahrenheit scale runs from, it's a very arbitrary zero. It actually was 0 Fahrenheit because at the time it was developed back in the 1800s, they thought that was the coldest temperature, 0 Fahrenheit. Turns out it's not, but it was the coldest they could achieve at the time. The boiling point on water is a really weird 212. Freezing point is 32, but that's the scale we here are used to. Now, almost any other country, they talk in Celsius. And a lot of scientific papers are done in Celsius. And it, again, is a little bit arbitrary. 0 is the freezing point of water. 100 is the boiling point. And then they divided that temperature into 100 equal sections. And you can see that the lowest temperature on the Celsius scale is minus 273 degrees. Now let's look at the Kelvin scale. The Kelvin scale says absolute zero is zero. There is no negative Kelvin. What does that correspond to on the Celsius scale? Minus 273. On the Fahrenheit scale, 460. Now I want you to look at something else that makes the conversion between these two scientific scales, Celsius and Kelvin, so easy. You'll notice for Fahrenheit, the difference between the freezing point at 32 and the boiling point at 212 is 180 degrees. That makes for some messy math, and we're not going to do Fahrenheit. Scientists don't do it, okay? Only people you will see doing it is the weather people, because we're used to that temperature scale here in this country. Now you'll notice on the Celsius scale, the difference between 0 and 100 degrees is 100. Also on the Kelvin scale, the freezing point of water and the boiling point of water, the difference is 100, from 273 to 373. So you can see the conversion between the two is really just a difference of 273. So you got to remember that number, 273. That's the difference between the two scales. So here's something you need to write down. How do you convert? We know that 273 Kelvin, and generally we don't put a degree sign with Kelvin, we do with Celsius, but 273 Kelvin, and we won't worry about the decimal points, equals 0 degrees Celsius. So Kelvin equals Celsius plus 273, right? 0 plus 273 gives you 273. Celsius, on the other hand, is Kelvin minus 273. And again, when you're doing these conversions, just remember the Kelvin will always be the larger number, and there will be no negative number in the Kelvin scale. Here are a couple of examples. 10 degrees Celsius, you'll stick it right in here, plus 273 is 283 Kelvin. Here's another one. 25 degrees Celsius, can stick it in here, plus 273 is 298 Kelvin. Conversely, if we put 298 Kelvin and subtract 273 from it, we will get 25. Write down, pause if you need to, write down these two conversion factors. You're going to have to know them. I'm not going to give them to you on a test. You have to know that 273. We use it so often. Okay, so you want to stop the video for just a minute, write these down, and see if you can convert them to Kelvin and to Celsius, depending on which way, using that formula. Stop it, try it, write down all 5, equals, and in a moment, we will check it. So pause the video here. Okay, hopefully you're unpausing the video. Here are the answers. We're converting from Celsius to Kelvin. You are going to add 273. Again, Celsius to Kelvin, add 273. Here's Kelvin to Celsius, so we'll have to subtract 273. Here's Celsius to Kelvin, so we're adding 273. And here's Kelvin to Celsius, so we're subtracting 273. So I hope that you got those right, and you'll be ready to do those on our next unit test. Have a great rest of your day.